Hello, welcome back to Cracking the Cryptic, and this puzzle is by JReg or JReg, I'm not even sure which, and it's called Little Killer Sandwiches, and I love it when clues do double duty, and they tend to in this puzzle. Not every single one of them, but almost all of them. And actually, I think there are talks of a duality pack in the works as a future monthly reward by Skunkworks. So I don't know if that will come to anything. I shouldn't probably have mentioned it, but I do like duality puzzles. They're very interesting, and I'm looking forward to having a go at this today. Now, don't forget that there are obviously many Patreon monthly rewards already in evidence, including some from the Skunkworks, but July's monthly reward was Paws's a 6x6 Sudoku butt. June's was Blobs' Lord of the Rings. And you can see the solves for that. If you're a $3 a month Patreon, you get the solves for those videos. Simon did all the solves individually of the Lord of the Rings puzzles. So they're all on Patreon. Do check us out on Patreon. There are some extra content. We've had the 600k celebration pack and Rockrat Zero's 600k bang puzzle as well. So always extra content. My crossword hard solves as well go on there, and all sorts of things, so do check it out. Now, that's Patreon. There's also our apps, which do feature Sandwich Sudoku and others, so do check them out. They are great fun and very worthwhile way of passing the time, if I say so myself. And of course there's Sven's Sudoku Pad and our merch, like this lovely mug, for instance, on there. Do check it out, either through the links under the video or through the store button on YouTube. But the first link under the video is to Little Killer Sandwiches by JReg, and the rules are as follows. Now the rules include anti-king. I'm looking around for my little Kingy McKing face friend. He must be here somewhere. Wait, he's coming into view, is he? Now, this is absolutely vital for me. If I don't have this sitting around, I will forget the rule and I'll be in trouble later when I've done all the Sudoku I can and I don't know what to do. So, normal Sudoku rules apply. 1 to 9 in every row, every column, and every 3x3 box. Also, anti-king rules mean that the same digit can't be a king's move apart from itself. So those two cells couldn't contain the same digit. Basically, the rule means that you can't have the same digit one diagonal step away from itself. That's the addition to normal Sudoku rules. Now, the clues outside the grid have two meanings. They give the sum of the diagonals indicated by the arrows. So the sum of that diagonal is 7. That will include repeat digits, I'm here to tell you, at least one. And in this column under the 7, the digits sandwiched between the 1 and the 9, wherever they appear in whichever order, but the digits between them will add up to 7. Might be a single digit 7 in that case. So these clues have two meanings. But that doesn't apply to the 36 clue up here, which doesn't, of course, see any row or column directly, and is therefore only telling us about its diagonal. So those are the rules today. Give the puzzle a try on the link under the video. I love combined puzzles like these. They often play out very interestingly. I'm not familiar with the name JReg, and apologise if they've been on the channel before and I haven't noticed. That can easily happen. We do thousands of videos, of course. Let's get cracking. Okay, so that 7 is telling us that these numbers are very small. What is the absolute minimum we could do here? Well, with a 1 there and a 1, 2 here, they have to be different being in the same box, and a 1 there, then we would get to the number 5. Now that is possibly, well, that is too short of the total that we're looking for. So if it's not 1, 1, 2, 1, and it's not, we have to increase by up to 2 in each cell. And that means we have 2 degrees of freedom to work with. And that means these could each be individually a 3, and this could be a 1, 4 pair. So those are the only digits that can now populate those. Oh, we've got a giveaway 5 down here from the diagonal clue there. And then the sandwich in this row that adds up to 5, well, it couldn't be a single 5 in those cells. Okay, I suppose we don't really know anything about it. We've got a 33 sandwich. Look at this, this is very cleverly done. The sandwich clue is of course the same at both ends because it has to be. A sandwich clue outside the grid is not like a skyscraper clue, which can be different from 2 different ends. A sandwich clue is always the same at both ends, and 33 is a huge number. Now, there is a secret we occasionally tell you about Sudoku, and I'm going to share it with you today. Every row, column and box always adds up to 45. It's magic, but it's true, because that's the sum of the digits 1 to 9, and that's the rule. However, if you take out the sandwich crusts, the 1 and the 9, the maximum sandwich, if you put 1 and 9 in those cells, would be 35. Now 33 is 2 fewer than 35, or 2 less than 35. And that means that there are outies summing to 2, by which I mean digits outside that sandwich, not in the crusts and not in the sandwich. And that means that there is a single 2 in one of those positions, and then just inside it there is a 1 or a 9, and at the other end of the grid a 1 or a 9. So the 1 and the 9 are either there or there. And I guess these digits have to be 1, 2 or 9. And what I sometimes do is colour green the cells that can't have the crusts in. I'm not sure there's enough sandwich clues in the puzzle to make this worth doing wholesale today, but let's start it off. So those green cells can't have 1 or 9 in. As we know, 1 or 9 is either a pair there or a pair there. Now, 33 is quite a big number for these diagonals. It may be analogous to 7 up there. So if you had a 9 and a 9 there, these add up to at least 15, well, they add up to 15 then. So the lowest digit we can have there is a 6. If you have 9, 8 here, the maximum, and a 9 on the other side, 26, the lowest digit you can have on the end is a 7. So I think for both of these diagonals we can do exactly this candidate marking, and it's exactly the same as that, only for higher digits. We had 3 digits there, 4 in each of those and 3 there, and the same pattern is happening here. Now, one of these is probably a 9 in this sandwich sum of 5, and one of, well, not sure, probably is not much to go on. And in truth, there are very few clues to go on in this puzzle. It's clearly very skillfully put together. I don't know. The 22 sandwich? The sandwich digits have to be at least 8, 7, 6. That would only be 3, and well, that would be 3 cells. The maximum for 3 cells would be 21. So the sandwich digits are at least 4, but the outies in this row add up to 13, because we can deduct that 22 from 35. I don't know. I don't think we get much there. I'm not sure. Here he is, Kingy McKingface, telling me, think about King's moves. Okay, I'm going to think about King's moves. But a King's move problem doesn't stop that being a 7, because you could still go 9, 8, 9. Maybe it's the interplay between these two things that we have to consider then. Okay. Here's my next question. What would happen if one of these diagonals didn't have 2 9s on? Okay, I can also see, and this is quite important, neither of them can have 3 9s on, because there would be a King's move 9 clash. You would have to have 2 there and 1 in box 9, and it would either create a King's move problem down here or a King's move problem up here. So 2 is the maximum number of 9s. Now, I think we can eliminate 6 entirely now, Because if there was a 6 on this diagonal, the other 3 digits would all be 9s. That might apply up here as well. If there was a 4 on this diagonal, the other 3 digits would all be 1s, and they can't be, for the same King's Move problem rule. Oh, there's an 8 looking at that cell, by the way. Anyway, that might be the disambiguator. We'll see. Now, what I was next going to ask is, what happens if there weren't 2 9s on here? If there was 1 9, then the other 3 cells would have to add to 24, and they'd have to have 3 8s, and that is not going to work, because it's exactly the same King's Move problem. In fact, in this case, given that 8, the 3 8s would have to be there and would create a King's Move problem here. This is very clever. I've not seen Little Killer and King's Move combined like this, but it's a brilliant idea. I really like this. However, now we know there are 2 9s on that diagonal. By the same token, there are 2 9s on this diagonal. And now we know that the 9s for each of these rows are in one of these cells that we've got highlighted. Now, how are we going to use that? One of these is a 9 in this box. I mean, I'm sorry about the pencil marking, because it could be a bit confusing. I suppose they have to alternate. It's either 9 9 there and there, or 9 9 here and here, so that we don't have any King's Move clashes. But which way round? I don't know. Oh, here's another thought. This 33 clue, there is going to be a 9 in one of these positions or in one of these. But hang on, these 9s alternate. We've just discovered that. And that means one of these 2 cells has a 9 in, and they both see that cell, so that can't have a 9 in. Similarly, one of these 2 cells has a 9 in, and they both see that cell. So neither of these cells can have a 9 in. And these 2 cells now do include the 9 and a 2, and one of these is a 1. And can we do the same here? Does there have to be a double 1 on this? If there wasn't, if there was only a single 1, there'd be 3 2s, there'd be a King's Move problem. There is a double 1 on this axis, I want to call it, on this diagonal. And therefore one of these 2, because there's 1 1 in one of those cells and 1 1 in one of those cells, one of these 1s will see that 1, and that is not a 1. This is where the 1 goes in the central row. This is the outie, 2, this is the 9, and now we know this can't be a 9, but they have to alternate down here, so we have to put them in those cells. Isn't this an absolutely gorgeously sumptuous beginning to a puzzle? It's so clever. And these are 9s, and we didn't actually use that 8 to disambiguate this as I was imagining we might. In fact, look at that 8 now. Using the King's Move, I'm not forgetting Kingy McKingface anymore, we can't put 8 in any of those cells, and 8 is in one of those 2. This pair is an 8-7 pair, which is quite interesting. So is this pair an 8-7 pair, to make the maths work on the diagonal. But I'm finding that interesting because that is a 7-8 pair, and they both see a number of cells that now can't have 7 or 8 in. Oh, and we've got this 9. Oh, and we've got this 9 in rows with sandwich clues in. Well, we've worked out we can't put the 1 there because that would be a 5. So the 1 is now in one of these positions, and there's either a 2-3 pair or a single 5 and a 1. I think I can work out which it is. If we were to put a 1 here, look at this 7 clue. A 7 clue in a sandwich, its sandwich can only be 1 or 2 cells because you can't use 1 in the sandwich. So 9, if that was a 1 in column 5, 9 would have to be here or here, but it can't be. So that's not the 1. Therefore, the 1 in row 8 is there. The sandwich is a 2-3 pair. Oh, and it doesn't tell me where the sandwich is in this column. The 9 is in one of those cells. I don't know where the 1 is. Could be there. So I'll come back to that. But we got this sandwich done, this 5 sandwich. Now, this 22 sandwich, we said earlier we were going to have at least 4 cells in the sandwich. And I don't think we can put the 1 there because the outies have to add up to 13. And that would only leave 1 cell for that. So this is the 1. These 4 green cells, I'll get rid of those greens because I don't think I'm colouring the whole grid this time. Those add up to 22 and we can't use 8 and 7. Oh, maybe the way we should do it is these add up to 13. Right, if that's a 7, these would have to be a 4 and a 2. If that's an 8, these would have to be a 3 and a 2. So that is a 2 every time. And that's now not a 2. This is 3 or 4. In fact, this pair add up to 11. And these, that might be the same digit each time, but I'm not certain about that. If that's a 4, it would have to go here. Wow. Well, this came together suddenly, didn't it? It's brilliant. Actually, that's a 7-8 pair, and I didn't mention this before, but it means none of these digits can be 7 or 8. Oh, this is what we learned earlier. None of these can be 7 or 8, because that's a 7-8 pair, and they're seeing them. So the maximum for these 3 is 4, 5, 6, which is 15, and would leave that to be a 7. So this is a minimum 7. That is 7 or 8. These are either 6, 5, 4. They can't be 6, 5, 3. So they are 6, 5, 4. That is a 7. I was going to start colouring 7s and 8s, but actually I can do better than that. I can actually just fill them in. Pretty sure this has to be right. I just want to check that if that was an 8, yeah, these would be 6, 5, 3. That just wouldn't work. It was really helpful information that 7-8 pair saw all of those. So we're done on this sandwich clue. That's now a 3. There's a 7 in one of those two and a 2 in one of those, and 4 and 6 still to be placed. So the 5 sandwich clue is done. The 22 sandwich clue is done. The 33 is effectively done. We're going to fit 4, 5, 6, 7, 8, 3, 4, 5, 6, 7, 8 here in some order. So that's almost all the sandwich clues done, not this 7 clue yet. It could have a 1 there, but otherwise it's confined up here. Okay, what about this 1, 2, 3 business? That can't be a 1 now. That's huge. This had to alternate 1s, didn't it? It was like these with 9s. Yeah, we worked out they couldn't be only 1, 1. So there are 2 1s. They're in those positions. Now, this is a 2, 3 pair. And there are therefore, again, a number of cells that can't have 2 or 3 in it because the 2 and 3 see them all. That seems less useful than last time. Now, that can't be a 1. The 1 in this column is in one of those places. The 9 is in one of those. I don't think that resolves how I do the 7 sandwich. I don't think it does, but it's a brilliant idea. Now, really all I'm left with that I haven't looked at, apart from this 7 sandwich, are this 36 diagonal and this 22 diagonal, which is stretched a bit by that being a 9, 9, 10, 1, 2, 3 there are the minimum. This is at most a 6. And if that was a 3, then these are at most adding up to 9. It's not that powerful. Oh, this is an 8. That's just the last digit it is in the box. That doesn't change this central column in any way. How do we make further progress? Let's do a bit of Sudoku. There's a 1 somewhere there. There's a 9 somewhere there. That might be quite interesting for the 7 sandwich. I mean, it could be 9, 7, 1 straight through the middle. If that's a 9, we either go 7, 1 south or 2, 5 or 3, 4 north. Okay, let's still keep trying to do some Sudoku if I can. These are from 4, 5, 6. They must include a 5. These are from 4, 6, 7 and must include a 7. These are from 4, 6, 2 and must include a 2. These, oh, there's a 1 right there. And the others are from 3, 4, 6 and must include a 3. King's move, of course. I've forgotten all about it all over again somehow. It's extraordinary how it can keep slipping my mind. Now there must be, I mean, I remembered it for the purposes of this diagonal. Anyway, there's a 7 in one of those cells. There's a 9 in one of those. I'm sure there is a King's move thing. Yes, look, I've got 8 there. That's not even King's move. That's just Sudoku. It was the King's move that gets this 8 resolved. Now, 8's in one of those cells. 8's in one of those two. 2 is in one of those 3. If that was a 2, that would be a 2. Now, down here, are there any King's move things going on? Those can't both be 2's. Not very helpful. Okay, I haven't messed up on the King's move completely yet. 1, 4, 6, 7 are all the candidates here. That can't be a 1. So 1's definitely in one of those cells. Oh, I thought the King's move was going to do something powerful. 7 is in one of those two. Oh, it couldn't be there because of the diagonal. That's interesting. Okay, maybe I need to focus on maybe both diagonals? 36 is low. I mean, the average for a diagonal would be 45, but it's not that low. 10 there at a minimum. 1, 2, 3, and well, 2, 3, well, not even 2, 3, 4. 2, 4, 5 here because of that cell and that cell. 2, 4, 5 is the minimum. That's 11. Plus 10 here is 21. The maximum here is 15. And the minimum is 1, 1, 3, 2, 6. So there's 9 degrees of freedom. That's plenty. That doesn't let me choose that 9 is not on the diagonal or something. So I've got to do something with this 7, surely. That must be the first port of call here. Now, I didn't think about that in the context of the King's move before. 9, 7, 1. Would that obliterate? It would put 1 in one of those positions. That's fine. It would put 9 there. What am I missing? Is it King's move or is it just ordinary Sudoku? It's something, isn't it? So easy to say. Oh, I tell you what, this sees all of 4, 5, 6 using the King's move. And it sees 7, 9 and 8. So that is 1, 2 or 3. Now this can't be a 1, 2, 3 triple. Which is just beginning to change matters a tiny, tiny bit. This is 4, 5 or 6. It sees 1, 2, 9, 8, 3 on the King's move and 7. I mean, I can't just candidate mark everything. It's not cricket to do that. That, though, is 3, 4, 5, or 6. Ah, there's a 1 there, looking at that cell. That is my king's move, so that is a 1. Well, that's huge, because that is on this 7 thing. Now, 9 is either there or there in this column. If it's there, this is a 7. If it's there, this is a 2, 5, or a 3, 4 pair. I thought this was going to be more helpful. There's definitely a 1 in one of those positions. The king's move is not going to resolve the remaining 1s. Okay, if that was a 7, that would be a 7. That would make that a 7. There'd be a 7 here. We've got a 7 here and here and here. We'd have a 7 there. We'd have to have a 7 right there. Is it about the diagonal? Oh, this is now that there's a 1 there, the minimum here is 2, 3, 4. Right, let's try the diagonal again. I think 2, 4, 5 was the minimum I had. That's 11. 2, 3, 4 there is 20. 1, 4, 5 is 30. Now there are only 6 degrees of freedom. That is still quite a few, but it's getting fewer. And I've got this 22 one as well. Oh, 8 is already confined here to one of those 2 cells using the king's move. If that wasn't a 1, this would be at least 2, 3, 4. 9, 18, 19. That would have to be a 3. That's interesting. But it's not quite conclusive enough. Is there any other problem with this being 2, 3, 4? I don't think so. But, okay, what I'd forgotten again is these green cells. Even though I highlighted them in green, they can't contain 2 or 3. So if that was 2, 3, 4, this would be a 4, and that would be a 2, 3 pair. Ah, you'd have a 2, 3 pair in the central column, and the 7 thing would have to go 1, 7, 9 then. Which it can do. Now I can feel there's tension around this. I can, but I can't quite eliminate it. Does that have to be an 8? No. 1, 9, 7, 2, 3. This is 8, 4, 5, or 6. So 2, 4, 5, 2, 3, 4, 11, 21, 22, 27, and a... Oh, I've got to a different total. 2, 4, 5 is 11. 2, 3, 4 takes it to 20. 21, 26, no. 30 is the minimum. So there are 6 degrees of freedom still. So, how can I use this? 2, 3, 4, or this diagonal, or both together. That would be a weird thought. For that not to be a 1, this would be a 1, that would be an 8, this would be 2, 3, 4. These would have to be 5 and 6, with a 9, 7 there. I can see how it would work if that was what happens, but I'd much rather see that it won't work. I'm missing something big now, come on. I mean, that 1 on the diagonal was so annoying earlier. That was absolutely resolvable, and I don't know what it was. 7's in one of those positions. 8's in one of those. I mean, this obviously doesn't go 8, 7, 9, but I don't think it's trying to particularly. 1, 2, 3. That can't be 9 or 7. I don't know. It's interesting that it's confined to those numbers. 8. Ah, it's so close to a resolution. I may have forgotten a clue. I've done this 22. I've done this 5. I've done this 33. I haven't done this 7. I know, I mean, I've done these 33 diagonals. I've sort of done the 7 diagonal. I've obviously done the 5 diagonal. So it really is only the clues I'm looking at. I haven't forgotten a clue, but I'm not using this 36 one right. So, does a digit in one place here force a digit into another that's also on it? Or is it just all about this? 9 can't be in those cells because of the sandwich clue. So 9, oh look, 9's in one of those 2 cells in this column because of the sandwich, and that means it can't be here because they're both touching it by king's move. So now 9 only has one place in box 5 because it was going to have to be in one of those 2, and it's here. Oh, that's so simple, and yeah, I just couldn't see it. That's 7, that's 7. This isn't. Now, that's not 7, that is. And there's no 7 in this group. This is a 1, 4, 6 set. 8, 7 is in one of these 2 cells, and therefore not in either of these, but we know it's not. We know it's in one of these 2 now. 7 is an X-wing between there and there, so that's where 7 goes in box 2. Okay, let's keep tracking. Now we've got a 7 on this crazy diagonal. That's interesting, because that has really exploded this. That's used up degrees of freedom here. Right, the minimum here now is 12, 7, 3 and 2. The minimum here is 10. That's 22. The maximum for these is now 14, and the minimum is 2, 4, 5, which is 11. So there's 3 degrees of freedom now. So 9 is not going to cut it, because even 4, 2, 9 is too much. So 9 can't be on the diagonal. 9 goes there. 8 just can be, I think. If we made it 8, 2, 4, 14, 21, 26, 31, 32, 36. I think 8 could work, but we get a 9. And we've got that 9, and the king's move says this is a 9, and this is a 9. That finishes on 9s. Okay. Now, what about this diagonal? Has anything happened to this? Not really. This can still be 2, 3, 4, and a 3 there. What about this column? These are all from 2, 3, 4, 5, 6. Can that still be a 4? That would be the 4 in column 5. That could be a 2, 3 pair. I think that is still possible. 7, 1, 2, 8, 9. These are from 3, 4, 5, 6. They all see this. No, they don't. There's not a cell that they all see, unfortunately. I thought maybe they all saw that, but they don't. However, 3 does see that cell, because 3 is definitely in one of those. 1, 9, 8, 7 is up here, 9. So that 7 clue is done. I've still got this 2, 3 issue, meaning that these can't be 2 or 3, or 7, 8 or 9. So that's 4, 5 or 6. This is 1, 4, 5 or 6. Now, 8 there, very difficult. 8, 2, 4. Two, 7, 3 or 3, 7, 2, and that would be another 4. What would that? I can't see how that would do anything particularly, but I might be missing it. There is another 2 or 3 up here and another 4, 5 or 6. I hope it's not some very obvious king's move again. That 2 or 3 has to be in one of those 2 cells, because this cell sees all of those 4. And this one is on that side. Okay, I might colour these 2s and 3s. So let's start here. Purple versus orange. Then there's a purple one in one of those 2 cells, and that's orange. That's different on the diagonal, so that's purple. There's a purple one in one of those 2 cells now. One of those, that's one colour, and the other colour is in one of these. Now, that can't be purple now because of the king's move. So purple is there or there. This isn't going to get it done, is it? Even with that. Well, purple, yes, okay. Where does purple go in box 5? Look, that's huge. Purple can't go in those 2 cells now because of those 2 and the king's move. And purple is there. So purple is here and not here by the king's move again. Purple is definitely here. Now purple is in one of those 2. Okay, well that was better. That was better. Purple is either there or there because we don't know whether it's 2 or 3. But it is 2 or 3 and it is on the king's move. Now, I don't know what the rest of this is doing. 7, 1, 9... 7, I mean, I'm getting somewhere with this. This is the way to go. Orange is on that side somewhere, but... and orange is in one of those 2 cells. Must be. So now orange is in one of these 2. And can I say that one of these has to be 2 or 3? If they weren't, the minimum they would be is 4, 5, 6. 15 plus 7, 22. Plus a 2 and 3, 27. 32, 33, 37. Yes, that's too many. So that is definitely orange. It has to be. And is 2 or 3. Now we're cooking a bit. Now orange is in one of those 2 cells. And this is a 2-3 pair. And yeah, there's not one there. The green, what was it? Purple. Purple is in one of those 2. I can get rid of these greens probably now because I've got a 2-3 pair here. Okay, so we moved on a little there. That is 4, 5 or 6, which is a bit like that. 3 in this column now is in, well, it's in one of those cells, so it's not here, so it's in the corner. That's 3 in the corner. That's 3 in the spotlight, losing its religion. So this is 4, 5, 6 or 8. 7 we know is in one of those cells. Does this have to be the other 2 or 3, the orange one? I don't think it does, because we still had some degrees of freedom once we didn't make this 4, 5, 6 with the 2 or 3 there. There is a 3 in one of those 2 cells. That's just Sudoku now. And I don't know whether 3 is orange or purple still. I still haven't disambiguated my orange and purple. That's quite irritating. If purple is 3, it's here. Then it would be here as well, which is very plausible. Yeah, then I wouldn't know at the top. If purple is 2, I've already got that as a 2. It would have to be here. And then it would be in one of those 2. And I don't see how that's resolved either. So no ruling on that. Oh, these are different anyway, orange and purple. I was just thinking about the king's move jobby again. Oh, there may be somewhere that purple and orange both see on the king's move now. that now can't be 2 or 3, like those cells. But I knew orange was over here, so that doesn't do anything. Where's purple up here? It's in one of these cells. Well, either that, in fact, oh no, purple is in one of those two here. Whereas orange could be in any of the 3 of them. Bother it. Has this diagonal changed? Come on. If that wasn't a 1, this could still be 2, 3, 4 as far as I can see, with that being a 3 and this diagonal is answered. But could it? Because that would then be purple. And this would be... Oh, hang on. Hang on. This would be orange, because if this was 9, 1, 3, 4, 2, 3, these are both coloured cells. And we've got orange in box 4 and purple in box 2. Purple would be the 2 and orange would be the 3. Is there a problem with that? This feels powerful. Oh, this pair are from 8, 2 and 3 because they involve purple and 8. So that's a triple in this column. I hadn't seen that before. Everything else in the column is from 4, 5, 6 or 7, and that one's not 7. Well, now, is this still able to be 4, 5, 2? Because that's quite annoying. I think it is. You'd have 6, 7, 8. 4, 5, 2, 3, 7, 2. I'm just checking the maths again. 23, 24, 29, 33. I mean, that's still under. So it's not actually 4, 5, 2. Or maybe that was higher than 2 or 3. I've got a 2, 3 pair in this column. Oh, goodness. Everything else is from 4, 5, 6 or 8. This shouldn't be being this difficult at this point. It's a very clever puzzle, but I'm missing something quite big here now. What am I missing? I'm trying to keep this diagonal addition in mind, trying to keep the king's move in mind the whole time. I really am trying hard. If orange was a 2, look what would happen. That would be orange in this box, and that it would be touching there. So orange is not a 2. There we go. Orange is a 3. Well, that's got to help. Purple is the 2. Orange is the 3. It just fails here. Isn't that weird? Right, let's colour away. We can colour some orange there. Orange is the 3, so it's got to be in this cell now. And in one of those 2, where is it in row 4? Oh, that's not orange. I don't know, it's in one of those 2. Okay, but the 2s then, there's another purple 2, and it's got to be here. We place it in box 9 now because of the king's move, Mr. Kingy McKingface again. This is 4, 5 or 6, but 1, 4, 6 are there, so this is a 5. That is 4 or 6. 3 and 5 are both here. They're both seeing that cell, which is therefore even in some way. Now, what have we got bursting onto the diagonal? Nothing interesting. Out of all that, there's a 3 in one of those 2 cells. So that's not a 3 because of the king's move. One of these 2 is orange, and one of those 2 is orange. Okay, well, that's interesting because it means this is the 3 in row 8. That's an 8 now and doesn't deserve a colour. And it means 8 is in one of those 2 cells in the central row. What else is 8 doing? Not much, but that's not a 3 now. This is from 4, 5, 6. One of those is a 5 in the column, so that isn't. Come on. This diagonal, we've got a 3 on it now. Now, does that have to be a 2, or could it still avoid it? This is a 7-2 pair. I've only just seen that. 3 and 5 are here. Now, does this have to be a 2? If it wasn't a 2, 3, 4, 1, that's still fine. 1, 9. 10, 13. These have to add up to exactly 9. So if this wasn't a 1, this would be 2, 4, 3. Now, where does that fail? I don't know. Let's keep looking at I might have to colour 4s, 5s and 6s now. In fact, I almost certainly will do. Okay, let's try it. Let's colour that red. That's in there in this box. It's in one of those two in box 1. It's in one of those 3, so it's definitely there in box 9, and it's not there. It's in one of these 3. And it's in one of those 3. This is, I don't know which digit it is. It's 4 or 6. So 8 is in those cells, so 5 is not. These are from 4, 6, 8. 5's definitely in one of those. 2 in the row, in the column I mean, that's not a 5. So 5's now definitely in one of these cells. This is 4, 6 or 8. Let's get rid of the yellow. I don't know, the yellow is still quite helpful to me actually. I'm not getting rid of that yet. So we coloured that one. Let's colour this one brownish, which goes there and is also in one of these. And is in one of those, so it's in one of these 2. I don't know, that's not all that helpful. And then I'm colouring 5s. And I mean, I might just as well look at 5s. What did we get? 5 in one of those cells. That can't be red, I've just realised, because we've definitely put red there. So red's in one of those cells, yes. So now red can't be in one of those 2 in box 5. So red's definitely in one of those 2. This is valuable, if I just could remember how it always works. So red's in one of those 2. Now that can't be red. 3, 7, 2, 1, 9. Red is 4 or 6. I don't know. It was about to be valuable and then it suddenly stopped short. But it's interesting when you get something like red into one of those positions. So if I was to say this colour, give this light blue. That can't be here or here by the king's move, so it's in one of those cells. So it's in one of these 2. I don't know, it doesn't really... Well, it's not the same as red, so it's in one of those 2. Ah, and then it is that brown colour, because it has to now be here. No, it could be 5, so that's not right. So it's not necessarily the brown colour, but it also might be the brown colour. So now my colouring has got incredibly confused. Now I really need to just focus on this diagonal and polish it off somehow, which I'm nowhere near doing. I've got 18 more to fit in. Ah, we've lost the 2 off the diagonal up here. Right, so I think that might change this. If this was 4, 5, 12, 14, 21, 24 at a minimum, 25, 30. If this was 4, 5, that would have to be a 3 and that would have to be a 6. And that would have to be a 6. Then 6 would be red and would be off the diagonal elsewhere. Just trying to work out what that would mean. It doesn't quite do it. It nearly does. We're down to 2 degrees of freedom now, since that became a 3. And that could never have been a 2 once. Well, maybe, I don't know. No, it was important that the 3 was there, because a 3 there didn't reduce the degrees of freedom. Now, if this isn't a 3, do we have the opportunity to say it must be more than 4? 2, 7, 1, 5. I don't think so. But whatever this is, it's 3, 4, 5, or 6. It must be the same as that digit. And then it must be the same as one of these. Okay, I'm going to get rid of all the colouring. Absolutely daring move here. And try colouring this one. That's the same as that, which is in one of those 2. Now, is that going to get me any further? It's not those 2, so it's in one of those 2. It's the same as that, so it's either, well, no, it could be there. I don't know, maybe that doesn't get anything done. If it wasn't a 3, it would be 4, 5, or 6, and it would be in all of these places for definite. Definitely it would be a 5. Right, this can't be 4 or 6. How about that? Because then it would go there, one of those 2, and there'd be nowhere for it in box 9. So that is not 4 or 6. It is therefore 3 or 5, and it's the same as this digit, which is 3 or 5. And it's on the diagonal. Now, if that was a 5, 10, 17, 22, 23, then we're going to need that to be a 4, 27, and these to be a 4, 5 pair, in which that would be a 5. So 5s would now be in these positions. Is this possible, is what I'm asking. There. Yes, that is possible. So that could be a 5. That's irritating. But we now know it's 3 or 5. Oh, come on. And it's there. Orange is definitely in one of those positions. Obviously, it's 3 or 5, so it's in one of those as well. And it's one of those 2. I'm going to keep marking this. Now, it's in one of these 3. If it's 3, it's there. If it's 5, it's in one of these. That's obvious. If it's... Does it have to be on the diagonal? Not clearly enough for me. Maybe 8 is now ruled off the diagonal. We don't have many degrees of freedom. If that was an 8, 8, 4, 3 is 15, 17, 24, 29, 30, 33, 37. 8 is not on the diagonal. So 8 in the box is here. That might help a little. That places 8 in box 2. That places 1 in box 2 on the 22 diagonal, no less. Places the last 1 in the grid as well. Now let's have a look at this diagonal. 14, we need 8 more. 3 or 5 there, 3 or 5 here. It's got to be a 5 here. That must help. That's a 5 now. Oh, and this had to be a 3 on the diagonal. So orange has become a 3. Orange, are glad I did that, said the dad joke. There we go. 3s. Oh, they're all done. That was well worth colouring then. Now, surely, can I add up this diagonal again? Let's do Sudoku first, because we got some 5s. One of those is a 5. We didn't get many 5s, but we got some. Done all the 3s. That's not a 5, for instance. That's where 2 is in box 2 now. Didn't even know I had any 2s remaining to do. That's not a 7. Ooh, 7 goes on the diagonal, and that's max. 7, 10, 19, 22, 23, 28. The other 2 cells add up to 8. They're both 4s, and we're in business, and we're finishing fast. he said, probably not finishing fast at all. Not too slow anyway. 6. This is a 5-4 pair. The king's move will come into its own in a moment, actually. Not needed down here at all. 4-6 there, I can't see how that's resolved, or that one, or this 4-5. That can't be 8 though, so we've placed 8 in the box. 4, 5, 6 are the only remaining digits. That's 5 or 6. This one is 4 or 5. Now, the king's move must resolve it. 4, 5 are both looking at that cell. There we go, and then 5 looks back into that box. Oh my goodness, that was a sweat, a struggle and a strain, but a really, really clever puzzle. And a real puzzle. There we go, 6 and 4. Whoo-wee! Glad I got it done, but that was tough stuff. Thank you for watching, as always on the channel. Hope you had a slightly better time with that than I did. Those diagonals were so strained. I think some of that colouring must have been necessary, but it was very difficult to do. Glad we got through it. Hope to see you again soon. Bye for now.